Hey guys, Mrs. Gray Math here. So we are going to continue our study of our system of equations with elimination. Yesterday, we walked through how to solve a system of equations with elimination when the coefficients were matching. Today, we're going to answer the question of how do I solve a system of equation with elimination involving unmatching coefficients. So to solve a system of equations by elimination where there are no common coefficients, meaning they're not matching, we first need to multiply one or both of the equations by a number to create a common or opposite coefficients. Okay. Once we do that, we're going to need to follow the following steps. The first is just like we did yesterday, is make sure that both of our equations are lined up or stacked. Okay, we want to make sure that our x's are over our x's and our y's are over our y's. It's all about organization when we are looking at solving with elimination. Then the rest of the steps are just as we did yesterday. We're going to add or subtract the equations to eliminate one of the variables, solve the new equation for the remaining variable, and then substitute into either of the original equations and solve for our remaining missing variable to create our ordered pair for our solution to our system. Let's take a look at number one. So looking at number one, I noticed that my equations are already lined up or stacked up. So notice that my x's are lined up with my x's, my y's lined up with my y's, and then the same, our constants are lined up with our constants. The only thing that I'm missing is I need a matching coefficient. Okay. So looking at both of these equations, I noticed that since my y's are opposite signs, these are probably going to be the easiest to eliminate to match up. So I need to look at both here. I have a 3y and a 6y. What can be done to that top equation where it can eliminate that negative 6y on the bottom? So on this one, I'm just going to multiply the entire equation by 2. Okay? Because when I multiply the entire equation by 2 and I'm distributing, I'll have 2x, and then 2 times 3y is now positive 6y, and 2 times positive 4 is 8. Okay? So I now have matching coefficients in my y's. I have a 6y and a 6y, and the great thing, they are opposite signs, which is going to make it so much easier when I go ahead and I need to do the elimination. Okay, so from here, we're back. We're just going to go ahead and add both of these equations together. Okay, so 2x plus 2x, I have 4x. My 6y, negative 6y plus 6y, they cancel out. And then I'm left with negative 4 plus 8, which is positive 4. Okay. I have gotten rid of my y. Now we're just simply solving for x. I'm going to divide both sides by 4, and I'm left with my x equals 1. Okay. Now I only have half of the solution to this system, because remember the solution to a system is an ordered pair. So I need to go back up to one of my original equations, and it doesn't matter which one I choose to use. I think for today I'm going to use the top equation, okay? And I'm going to take this equation, and now I'm just going to substitute my answer where x equals 1. So wherever there's an x, I'm going to plug in a 1. So here I'm just going to rewrite my equation that I want to use just so we can take a look. And now I have 1 plus 3y equals 4. Whoops, equals 4. That's not a 4, that's 5. Ooh, okay, equals 4. See, got a step ahead of myself. And now I'm going to solve the equation. So I'm just subtracting 1 from both sides. cancels out. I'm left with 3y equals 3. And now I'm simply just going to divide both sides by 3. Y equals 1. And the ordered pair that solves this system is 1, 1. Let's take a look at number 2. So number 2, once again, my coefficients are all stacked up, but I need to find a common coefficient. So here I'm going to look at my y's again because they have these opposite signs. So that's probably going to be the easiest one to go ahead and eliminate. So looking here, I'm going to multiply this bottom equation, everything on the bottom, by 2. Okay. And when I do that, I'll have, just going to distribute here, I have a 2x, and then 2 times negative y is minus 2y, and 2 times negative 13 is negative 26. Okay. And then I'll take my first equation, I'm just going to rewrite this to the bottom here, so it is stacked up, 3x plus 2y equals negative 9. Okay. And now I can add both of these equations together. Okay, 3x plus 2x, I have 5x. My positive 2y, negative 2y, those cancel out. And then negative 9 plus negative 26 is negative 35. And now I'm just going to divide both sides by 5, which leaves I have an x value of negative 7. So now I'm going to go and choose one of my original equations. I think what I'm going to do is just use this second equation here. And I'm going to substitute in wherever I have an x value, I'm going to substitute in that negative 7. So I'm going to go back up here, take this equation, and here I have x value, so I'm going to plug in negative 7 minus y equals negative 13. And now I'm simply going to be solving for my y value. So I'm going to add 7 to both sides. I have negative y equals negative 6. And then I'm going to divide by a negative 1, so I have that positive y, where y value equals 6. So the solution to this system of equation is at the ordered pair of negative 7, 6. So now let's look at number 3. So from here, the first thing is I want to go ahead, and I think this is going to be, I'm just going to go ahead and let's eliminate our x's. So I'm going to work with my top equation. I'm going to multiply my top equation, and I'm not just going to do this by 3, but I'm going to do this by negative 3. The reason why is when I multiply this by negative 3, my x's will have the same coefficients with the opposite signs. So from here, I'll just distribute. I have negative 3 times 2x is negative 6x. Negative 3 times y is negative 3y. And then negative 3 times 10 is negative 30. Okay? And since I still have these stacked up, my 6 is here. I have 6x minus 6x. Well, that cancels out. That's 0. And then I have my 3y minus 3y. Well, that cancels out, so that is 0. And then I'm left with my 30 minus 30. That is also 0. So here I would have a solution of infinite solutions. And I know that this was infinite solutions because when I got to the very end, I have 0 equals 0. We know that this is a true statement. Go ahead and take a look at number 4. Stop this video and try number 4 on your own. Okay, so let's see how you did on number 4. So the first thing I'm going to do is I'm going to go ahead and take my top equation, and I am going to multiply this entire equation by negative 2. Because in doing so, I feel like I could easily eliminate my y values. So when I do that, I'm left with, let's see, negative 2 times 3x is negative 6x. Negative 2 times 4y is negative 8y. And then negative 2 times positive 6 is negative 12. Okay? And my bottom equation will stay the same. So I have 7x plus 8y equals 10. And then from here, I'm going to add them together. So when I add both of these equations together, I'm left with x. My 8y's cancel out. And then negative 12 and 10 leaves me with negative 2. Okay, so I know my x value is negative 2. So now I'm going to go back up to my top equation. And here, I'm just going to substitute in a negative 2 for my x value. Okay, so let me rewrite this equation, substituting in negative 2 for x. And now I have 3 times negative 2 is negative 6. Plus 4y equals 6, and I'm just going to solve for y. So I'm going to add 6 to both sides. Leaves me with 4y equals 12, and then divide both sides by 4, y equals 3. So the ordered pair solution for this equation is negative 2, 3. Let's take a look at number 5 together. So looking at number 5, both of my equations, notice that they're not in the same format. So I need to rearrange one of these equations so they're in the same format. I think I'm going to go ahead and rearrange this second equation, and I'll have my x's and y's together. So I'll put that into standard form because I notice I can easily just add 6y to both sides. Okay. So when I do that, my top equation, it's just going to stay the same, and I'm going to rewrite that over here so I can work on keeping them stacked or lined up. And then my bottom equation, when I move the 6y, we will have 3x plus 6y equals 12. Okay, so now they're both in the same order. And I can easily look and decide, well, how am I going to manipulate this equation next in order to solve with elimination method? So remember, our goal here is to create where we have same coefficients with opposite signs. So looking at both of these equations, I think I'm going to have to multiply both of the equations by something, because looking at 2 and 3, well, there's nothing I can multiply 2 by to get it even close to 3. And the same thing with 4 and 6. So what I'm going to do is I'm going to multiply both of my equations so I can create a 6x. Okay. So here, the first thing I'm going to do, I'm going to multiply my top equation by 3. And when I do that, I have 6x plus 12y equals 18. Okay. Now I'm going to look at my bottom equation. So my bottom equation, I want a same coefficient of 6, except I want it to have the opposite sign, subtraction sign. So on this equation, I'm going to multiply this by negative 2. Okay, when I do that, I have negative 6x and minus 12y equals negative 24. And now let's see, 6x minus 6x, it's left with 0. 12y minus 12y is left with 0. And then 18 minus 24 is left with negative 6. So I'm left with the statement of 0 equals negative 6. Since 0 equals negative 6 is a false statement, okay, then this is no solution. So this is a system of equations that does not have a solution. Let's take a look at number 6. So in number 6, the first thing I'm going to do is I want to have them in the same format. So I'm going to take my top equation and I want to move this negative 2y over on the same side of my x. And I can do this by adding 2y to both sides. So it will leave me with 5x plus 2y equals negative 3. And then my bottom equation, well, that's just fine as is for now. I have 3x plus 3y equals 9. Now that I have them in the same order, I need to take a look and decide, well, which variable am I going to look at eliminating? And I think that where I personally am going to start is I'm going to look at my y's. Okay, what do I need to multiply one or both equations by in order to create a matching coefficient with opposite signs? And I'm going to start with my y's. Okay, on the top equation, I'm going to change both of these into, I think if I can make these into 6's and 1, that will work just perfectly. So the first on my top, I'm going to multiply my top equation by positive 3. And then I will have a 15x plus 6y equals negative 9. Okay. And now on my bottom equation, I need to multiply this entire equation by something that will not only give me a same coefficient of 6 on the y, but a negative 6. So I'm going to multiply this by a negative 2. And I'm left with negative 6x minus 6y equals negative 18. Okay. And now I'm just going to add these two equations together. So I have 9x. My y's cancel out. I'm left with negative 27. And now I'm solving for x divided by 9. So my x value is negative 3. Now I have half of the ordered pair to my solution. I'm going to go back up into one of these equations, and wherever there is an x, I'm going to plug in a negative 3. I guess I'll just go ahead and I'll take this second one. So I have 3, negative 3, plus 3y equals 9. Now, so that's negative 9 plus 3y equals 9. Add 9 to both sides. So I'm left with 3y equals 18. And then divide both sides by 3 to give me a y value of 6. So the ordered pair to this system that would make both of these true would be negative 3, 6.